Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 2, Multiple Choice question number 38. In this question it is given that a car is moving with speed 108 km per hour perpendicular to a wall on a pavement. This pavement is horizontal. To avoid collision, the driver takes a turn and finally runs the car parallel to the wall with the same speed with which it was coming towards the wall. Coefficient of friction between the tire and the pavement has been mentioned as 0.6. Acceleration of free fall like g to be taken as 10 meter per second square, and it has been assumed that the entire load of the car is acting on the front axle. The question also says the turning process is the fastest one on this pavement. So check validity of the following statements. What are those statements? The car follows a circular path during the turn. The car follows a parabolic path during the turn. C is minimum radius of curvature of the path is 75 meter. Initial distance of the wall must be greater than 75 square root of 75 root 2 meter. So we will solve this question and see which all options are correct. This is your car. Well, speed has been given as 108 km per hour. We should convert it into 30 meter per second. That will come as 30 meter per second. So initial velocity was 30 meter per second and final velocity also 30 meter per second. And suppose the car has taken this curved path. And from here to here, it took a time delta t to reach. So we can write an expression for average acceleration of the car. That is final velocity minus initial velocity divided by the time lapse, that is delta t. For the delta t, the time interval to be minimum to reach from here to here, from this equation what we are getting, that A average, acceleration average, should be maximum. But there is a restriction on maximum speed on the curved path, as you know, because on the curved path the car will experience a centrifugal force that will try to slide it outwards or push it outwards from the path. To balance this force, there is friction force available, so that friction force will act exactly opposite to that centrifugal force. So when the speed is low, friction force will be low. As the speed goes high, the friction force magnitude will also go high. But it can reach maximum to a limit, that is mu into n, and normal reaction is equal to mg, because there is no motion perpendicular to the ground. So n is equal to mg. So to avoid skidding, we should write this expression. Friction force should be greater than or equal to mv square by r. But maximum friction force can go till this, so we will write this. So from here we will be getting mu z should be greater than and equal to v square by r, and v square by r you know is the acceleration a of the car. So it means when we take the equal sign, a maximum can be equal to the mu g. So you put the value of mu and g and you will be getting 6 meter per second square. So in the question it is given fastest way to turn. So it means the car should throughout on the curved path travels with maximum acceleration. So A average will be equal to the A max, and we can say it as A for convenience. So throughout the motion of the car on the curved path, the acceleration should be maximum. It should be equal to A max and should be constant. To satisfy this condition, fastest way. Now A average we have written in the vectorial form we have written earlier. We will pick up that equation and we can write Vf minus Vi by delta time minimum time. We will put the value of final velocity, that is 30 into minus j cap minus 30 into I cap divided by delta t minimum. So this will be the magnitude of the A average, and this will be the unit vector. Means in this direction the acceleration of the car should work, and its magnitude should be through and through the same. And what is this direction? This direction, if you go with the vector, you can see that the green, this arrow will be its direction, that unit vector direction. So what does this signify? This signifies that the acceleration will be maximum and constant on this curved path throughout, and the direction of this acceleration will always be perpendicular to the, or direction of the acceleration will always be in this direction, and this direction is perpendicular to your AB line. So it means force acting on the car will always be towards the this side at each and every point on the curve. So this situation is analogous to the, or similar to the projectile motion, where the force is acting in only one direction but the particle is moving in a curved path. And what kind of curved path that achieve is the parabolic path. So here also the fastest way to turn will be the car should move in the parabolic path. Now if we take the magnitude of acceleration, so it will be 30 root 2 divided by delta t minimum, because magnitude of this will be 1. This is unit vector. So from here we will get this delta t minimum, and that will be 5 root 2 second. Since acceleration is making an angle of pi by 4 with the x-axis, hence component of acceleration on the curved path along the x-axis will be a cos pi by 4, and that will be 6 by root 2 meter per second square, and it will be towards the negative direction of the x-axis, because towards the wall intention is that car should not strike with the wall, so it should be retarding. The acceleration in this direction should be retarding in the x direction. So the direction of acceleration in the x direction will be negative to the direction of x-axis. To calculate the distance travel towards the wall while coming with the velocity 30 meter per second towards the wall by the curve, we can calculate as by the simple formula like this. S is equal to initial velocity into, we know that the total time taken is from here to here delta t minimum to satisfy the question's requirement, minus half into x into delta t minimum square. We'll put all the value and we'll be getting S is equal to 75 square root of 2 meter. So if the car distance would have lesser than this from the wall, the car would have collided to the wall. So to avoid this collision, the gap between the car and wall must be greater than 75 root 2 meter. So this is another part of the answer. Now from the diagram, if you refer the previous page, velocity along the line AB will be Vi cos pi by 4, that is 30 root 2 meter per second. And we also know from mathematics that minimum radius of curvature in parabola is at the apex of the parabola. So if we calculate, or if we consider the forces acting and the velocity and everything at the apex, we should be able to get minimum radius. So here is the apex we have assumed. We know that the at apex only component of the velocity will be along the line AB, because along the line AB there is no force acting. All the forces acting perpendicular to it. So there will not be a change of velocity in the direction of AB throughout the motion of the car onto this curved path. So if this is the centrifugal force at apex, mv square by r minimum, mu mg will be the friction force. And since so these two forces should be equal to avoid skidding, so we will write this, and from here we can calculate r minimum as 75 meter. So the minimum radius of the curvature of the path is 75 centimeter, we can say. So in overall solving, we have got that the option B, C and D are correct. Hopefully you understood the concept. This question is very interesting. In case anywhere you found it difficult to understand or you could not get it, please do write in the comment box. I will elaborate on your doubt. Thank you.